Year 1700. Mongolian steppe. Wind slicing across frozen plains. You crouch beside a yurt. Its felt walls must trap warmth, prevent frostbite, and withstand relentless snow. The yurt's wooden lattice frame forms a rigid circular skeleton, each interlocking member resisting harsh steppe winds, channeling lateral pressure downward and stabilizing the walls for precise roof placement. Compressed felt is stretched over the yurt's lattice, pressing tightly against every node to eliminate gaps, trap hearth heat, prevent convective currents, and maintain consistent warmth above the insulated floor. The roof crown ring anchors radial rafters atop the lattice, distributing accumulated snow load evenly, preventing bending and converting vertical forces into outward pressure along the circular walls of the yurt. The smoke hole, positioned within the yurt's crown ring, vents combustion directly upward, preventing soot deposition on felt and keeping upper insulation layers dry despite persistent indoor heat. Floor insulation, formed from layered animal skins beneath the lattice, elevates occupants above frozen ground, slows conductive heat loss, and allows structural loads from walls and roof to pass safely through base. The yurt's northern door flap aligns against prevailing gusts, overlapping threshold skins, weighted and tied to lattice posts, preventing direct wind penetration into the interior and preserving thermal integrity. Tension bands encircle the yurt's exterior, compressing lattice and roof poles, converting lateral storm pressure into circumferential tension, preventing bowing and securing radial rafters in the crown ring under wind stress. Overlapping felt panels cover the yurt from roof to floor, channeling melting snow away from the lattice walls, preventing moisture from reaching structural joints and preserving insulation efficiency throughout the winter. Roof rafters slope outward from the yurt crown, shedding ice toward felt edges, distributing snow, weight evenly across multiple members, and protecting the wooden lattice from deformation under winter loads. Felt density increases near the yurt floor, concentrating insulation around occupant seating, trapping warmth at low levels, pressing against lattice and floor insulation, and maintaining a warm zone beneath rising smoke. The hearth is placed centrally in the yurt beneath the smoke hole, radiating heat evenly across the circular floor while keeping upper felt layers dry and structurally stable under roof weight. Roof poles are angled precisely, maximizing headroom inside the yurt while supporting heavy snow load, transferring vertical forces through rafters to the crown ring and down to the lattice walls below. Ground stakes driven through the yurt's base lattice anchor the structure, resisting wind uplift, distributing lateral forces around the circumference, and maintaining stable wall positions during extreme steppe storms and frozen ground shifts. Felt edges are tucked beneath the lattice at the floor, pressing against insulation layers to prevent cold air infiltration and creating a continuous barrier that protects the interior from gust-driven drafts. The smoke hole ring is reinforced and adjustable, controlling airflow through the yurt, maintaining interior heat, preventing felt deformation, and ensuring smoke rises efficiently without condensation or loss of warmth. The yurt's raised door threshold blocks drifting snow from entering, working with weighted flap and floor insulation to prevent ground-level gusts from breaching the interior, maintaining thermal and structural integrity. Radial rafters are evenly spaced from the crown ring to the lattice top, distributing roof weight symmetrically, preventing localized stress, and maintaining the yurt's circular geometry under heavy snow accumulation. Exterior felt tension is maintained across the yurt walls, keeping panels tight against the lattice, preventing flapping during sub-zero winds, and maintaining consistent contact for effective insulation across the entire surface. The hearth smoke pathway is designed to rise through the yurt's central smoke hole, preventing condensation on roof felt panels, preserving insulation efficiency, and maintaining structural stability of rafters and crown ring. Lattice intersections are double bound with rope at critical points in the yurt, transferring structural loads efficiently, preventing weak points from failing under snow or lateral wind pressure, preserving circular wall integrity. Roof crown height is adjustable on the yurt lattice tops, managing interior smoke accumulation, maintaining proper alignment of radial rafters, and preserving the circular structural geometry under varying load conditions. Felt layering near the yurt floor creates an insulated microclimate, pressing against lattice and floor skins, slowing heat loss, and concentrating warmth where occupants sit or sleep throughout the frigid steppe winter. The door flap is reinforced with extra felt skins, tied to lattice posts and base, resisting extreme wind pressure, preventing inversion or tearing, and maintaining the yurt's interior thermal barrier. Corner lattice sections are angled within the yurt to resist lateral compressive forces from roof weight and wind, preserving the circular wall geometry and maintaining stability under uneven winter loads. Roof poles notch securely into the crown ring, preventing sliding under snow accumulation, transferring weight down rafters into the lattice, and maintaining the yurt's circular structural integrity during storms. The hearth remains centered, balancing warmth across the circular floor, interacting with floor insulation and thick felt layers, while smoke rises directly through the crown ring smoke hole, keeping the roof dry. Base lattice width is expanded beneath the yurt, distributing structural loads over frozen soil, resisting frost heave and maintaining stable contact between stakes, floor insulation, and walls throughout winter freeze-thaw cycles. Felt edges at the yurt base are weighted with stones, preventing uplift from gust-driven winds, maintaining continuous contact with lattice and floor insulation, and reinforcing the thermal and structural barrier against storms. The roof crown interior is lined with additional felt, retaining heat near the apex, pressing against radial rafters, reducing heat loss, and contributing to a layered thermal profile within the yurt. Door flap overlaps are arranged carefully to prevent direct wind penetration into the yurt, forcing air through multiple barriers, maintaining interior warmth, and preserving structural integrity of lattice and floor insulation. Roof rafters are spaced deliberately to balance ice accumulation on the crown ring, preventing localized bending or deformation, maintaining the yurt's circular roof geometry, and ensuring load transfer to lattice walls. Interior felt hangings are suspended above, seating areas in the yurt, reducing convective drafts, channeling heat around occupants, and working with the hearth and roof slope to concentrate warmth efficiently in the lower interior. Before covering the yurt, the lattice framework is tensioned precisely, preventing wall or roof warping, preserving circular geometry, and allowing felt covering roof crown and tension bands to integrate into a stable, winter-ready structure. The hearth smoke hole is capped on the yurt to control soot buildup efficiently, directing smoke upward, preventing felt staining, and preserving insulation and structural integrity during extended winter fires. Door poles are placed precisely within the yurt frame, allowing the flap to close completely, sealing the interior against storm winds while maintaining alignment with lattice walls and weighted threshold. Roof pole lengths are calibrated within the yurt to support maximum snow load, transferring weight evenly to rafters, crown ring, and lattice walls, preventing bending or structural distortion under accumulation. Felt seams are overlapped across the yurt's exterior, forming a continuous weatherproof barrier, preventing snow and wind infiltration, maintaining thermal integrity, and ensuring contact with lattice and tensioned roof poles. The base perimeter of the yurt is insulated with extra skins, resisting frost penetration, slowing ground heat loss, and stabilizing lattice and floor layers under freezing steppe temperatures. Lattice joints beneath roof poles are reinforced at high stress points in the yurt, distributing load from rafters and crown, preventing structural failure under snow weight or gust-driven lateral pressure. The smoke hole center ring within the yurt allows evenly dispersed smoke throughout the interior, promoting efficient venting, reducing condensation on felt, and preserving heat retention while maintaining roof felt integrity. Door flap ties are secured to the yurt lattice, preventing wind from peeling edges outward unexpectedly, maintaining full closure and ensuring thermal insulation and structural alignment during high-velocity gusts. Radial rafter ends are seated firmly into crown ring notches, locking the yurt roof structure in place, distributing vertical load evenly, and preventing lateral displacement or stress concentration on lattice walls. Compression of the felt roof reduces snow infiltration during extreme storms, pressing panels tightly against rafters and lattice, shedding moisture efficiently, and preserving the yurt's insulation and structural stability under heavy accumulation. The interior hearth's proximity to the yurt center balances warmth evenly across the circular floor, radiating heat to walls and floor insulation while maintaining effective smoke venting through the crown hole. Lattice frame flexibility in the yurt absorbs gust shock without structural collapse, allowing members to bend slightly under pressure, distributing wind loads circumferentially and preventing fractures in walls or roof. Felt skirts are extended below the yurt lattice to deflect snow away from walls, preventing accumulation at the base, maintaining floor insulation dryness, and reinforcing exterior thermal and structural continuity. Roof poles are angled to maintain the yurt's circular plan under heavy load, transferring snow weight evenly to lattice walls and the crown ring, preventing deformation or compression failure. Door flap is fastened with loops to the yurt lattice, preventing wind inversion inside, maintaining interior closure during storms, and securing the thermal envelope against gust-driven infiltration at floor level. The roof crown is reinforced within the yurt to resist compressive weight from accumulated ice, strengthening the apex, stabilizing radial rafters, and preserving circular geometry of the walls under winter load. Felt thickness varies vertically across the yurt walls, prioritizing heat retention near the floor, concentrating warmth around occupant seating, and reducing convective loss through upper layers while maintaining venting at the smoke hole. The yurt lattice frame is tied at its base, resisting uplift from strong winds, distributing lateral forces along tension bands, and maintaining stability of walls and roof during sub-zero step gusts. Roof poles overlap felt panels on the yurt, preventing snow penetration at junctions, maintaining insulation continuity, and reinforcing the connection between rafters, crown ring, and lattice framework under winter loads. The smoke hole ring is reinforced in the yurt to resist deformation under roof load, ensuring consistent venting, maintaining felt tension around the crown, and preventing sagging or water intrusion during storms. Door flap is lowered completely to seal the yurt interior against drifting snow, pressing weighted edges against the threshold and lattice posts, preserving interior heat and preventing wind penetration. Radial rafters interlock with the yurt crown ring, forming structural rigidity, distributing snow weight evenly, preventing lateral displacement, and maintaining precise alignment between rafters and lattice walls for circular stability. Felt roof layers are pressed firmly on the yurt, shedding ice efficiently, maintaining tight contact with rafters and lattice, and preventing gaps that would allow moisture or wind intrusion during storms. The base lattice is positioned above the frost line in the yurt, reducing freezing risk, preventing uplift from frost heave, and maintaining a secure interface between floor insulation and surrounding walls. Interior felt hangings are suspended in the yurt near the smoke hole, blocking drafts, reducing convective currents, directing warmth toward occupants, and protecting upper felt panels from condensation or cold infiltration. Hearth stones are arranged in the yurt to radiate heat toward walls, evenly distributing thermal energy, reinforcing floor, insulation contact, and improving warmth retention in the circular living space during sub-zero temperatures. Roof pole ends are notched for secure placement in the crown ring, locking radial rafters into the yurt, preventing sliding under snow load, and maintaining alignment with tension bands and lattice walls. The yurt door flap is reinforced with leather straps, resisting gust-driven peeling, maintaining closure against strong winds, preserving thermal insulation, and ensuring the flap remains fully sealed against the weighted threshold. Lattice intersections in the yurt are braced diagonally, resisting lateral wind pressure, distributing stress across multiple members, preventing wall deformation, and maintaining the circular structural form under step storm forces. Felt edges are tucked under the yurt lattice, preventing snow intrusion during storms, maintaining continuous insulation along the base, and protecting floor layers from moisture and wind-driven cold air. Roof crown height is adjusted according to snow accumulation levels, maintaining interior clearance, optimizing smoke venting, and preserving alignment between radial rafters, crown ring, and lattice walls under variable winter loads. The interior hearth smoke is vented directly through the yurt's central roof hole, minimizing condensation on felt, preserving insulation efficiency, and maintaining a dry, structurally sound upper interior space. Radial rafter angles in the yurt are calculated to evenly distribute snow weight, transferring forces through the crown ring to lattice walls, preventing bending and preserving circular geometry under heavy accumulation. Felt thickness in the yurt increases near the floor, concentrating insulation where occupants sit, retaining warmth longer, pressing against lattice and floor skins, reducing convective heat loss. Ground stakes are hammered deep through the yurt's base lattice, anchoring the structure, preventing displacement and distributing gust forces around the circumference during step storms. The door threshold is elevated within the yurt, blocking water and ice from entering, maintaining interior thermal integrity, working with weighted flap and floor insulation to prevent ground-level infiltration. Roof pole tension is adjusted in the yurt to resist compression under ice loads, stabilizing rafters, maintaining crown ring alignment, and preventing sagging or bending of the circular roof. Felt seams are overlapped tightly across the yurt exterior, forming continuous weatherproof barriers, preventing wind-driven snow leakage, and maintaining insulation and lattice contact under extreme step storms. The smoke hole is reinforced with extra felt layers in the yurt, preventing collapse under snow weight, maintaining proper airflow, and protecting surrounding roof panels from moisture damage. Roof rafters are spaced carefully within the yurt to optimize structural strength against heavy snow, ensuring weight distribution to the crown ring and lattice without bending or stress concentration. The yurt's base perimeter is insulated with skins, reducing heat loss to the ground, stabilizing the lattice frame, and maintaining a thermal barrier between frozen soil and interior floor layers. The interior hearth is centered beneath the smoke hole, radiating heat evenly across the circular floor, maintaining consistent warmth, and coordinating with floor insulation and felt layers for maximum efficiency. Lattice joints in the yurt are bound with rope tension, resisting structural deformation from snow and wind loads, distributing force across multiple members, and preserving circular geometry of walls and roof. The roof crown ring is supported by radial poles, transferring weight to the yurt lattice, stabilizing rafters, maintaining circular alignment, and preventing apex compression from accumulated snow or ice loads. Door flap is fastened to the yurt lattice with toggles, preventing wind from forcing entry, maintaining closure against gusts, and preserving interior heat around the threshold and floor insulation. Felt skirts are extended below the yurt lattice, deflecting wind-blown snow from walls, preventing accumulation at the base, and maintaining floor insulation and interior thermal stability during storms. Roof pole lengths are adjusted for optimal overlap with the crown ring, ensuring continuous load transfer through rafters, preventing sliding, and maintaining the circular geometry of the yurt under snow weight. Interior felt panels in the yurt are arranged to channel heat around occupant space, reducing drafts, concentrating warmth at seating areas, and interacting with floor insulation and central hearth heat. Radial rafters are notched into the crown ring, distributing weight evenly across the yurt roof, preventing concentrated loads and maintaining alignment between rafters and the circular lattice walls. The yurt door flap is reinforced with multiple felt layers, resisting sub-zero step winds, preventing inversion or tearing, and maintaining thermal and structural integrity of the entrance during storms. The smoke hole is capped to regulate airflow in the yurt, retaining interior warmth, preventing heat loss through the apex, and maintaining effective venting of combustion gases. Felt compression around roof poles prevents snow infiltration through joints in the yurt, maintaining continuous insulation, securing rafters against lateral movement, and preserving thermal and structural stability during winter storms. The base lattice is widened in the yurt to resist frost heave during extreme winters, distributing loads over frozen soil, preventing uplift, and stabilizing floor insulation and wall connections. The roof crown is lined with additional felt in the yurt, retaining heat near the ceiling, pressing against rafters, reducing heat loss, and contributing to a layered thermal profile inside. The lattice framework is tensioned precisely before covering the yurt, avoiding wall or roof warping, maintaining circular geometry, and ensuring proper integration of felt, rafters, crown ring, and tension bands. Hearth stones are positioned in the yurt for even thermal radiation across the circular floor, maximizing heat transfer to walls, floor insulation, and surrounding felt layers for consistent occupant warmth. Door flap overlaps are tightly arranged, preventing wind-driven snow from entering the yurt, maintaining closure at the threshold, and reinforcing contact with lattice posts and floor insulation. Radial rafter ends are seated securely in crown ring notches, locking the yurt roof in place, preventing sliding under snow, and maintaining structural continuity with lattice walls. Felt roof density is varied in the yurt to prioritize warmth at occupant level, concentrating insulation near the floor, reducing convective loss, and interacting with ceiling and wall panels for thermal efficiency. Lattice intersections are reinforced in the yurt to transfer structural loads efficiently under snow, preventing weak points, distributing forces through the circular framework, and maintaining roof and wall geometry. Ground stakes are anchored into frozen soil beneath the yurt, resisting lateral wind forces, maintaining base stability, and transferring gust pressure into the lattice frame and tension bands. Roof pole angles are adjusted to maintain the yurt's circular plan under heavy load, distributing weight evenly to rafters and lattice walls, and preserving roof geometry. Interior felt hangings block drafts rising from floor gaps in the yurt, directing heat toward occupants, reducing convective loss, and protecting upper panels from moisture or wind intrusion. The smoke hole ring is tensioned in the yurt to resist deformation during heavy snow accumulation, maintaining proper venting, felt alignment, and structural integrity at the roof apex. Roof poles are notched into the crown ring to prevent sliding from accumulated ice in the yurt, securing rafters, distributing weight evenly, and maintaining circular structural integrity under load. The door flap is reinforced with extra felt skins, maintaining closure against wind, preserving interior warmth, and resisting tearing or inversion during gust-driven winter storms on the steppe. Felt edges are weighted and tucked beneath the yurt lattice, preventing uplift by gust-driven winds, maintaining insulation contact with floor and walls, and reinforcing thermal and structural stability of the exterior. By observing the yurt after a season of sub-zero exposure, the cumulative logic of its construction becomes evident. Every element, the circular lattice, The radial rafters, the crown ring, the tension bands, the overlapping felt, the layered floor skins, operates as part of a tightly integrated system. Each structural decision responds directly to physical forces, wind pressure, snow load, frost heave, and convective heat loss. The northern, Dr. Flap, weighted and reinforced, prevents turbulent air from disrupting the interior microclimate. Ground stakes and expanded lattice bases anchor the frame against uplift, while angled roof poles and notched rafters distribute heavy snow evenly across the circular walls. Felt density is varied, concentrated near the floor where heat naturally collects, while interior hangings further channel warmth toward occupant spaces. Even the smoke hole functions as a controlled vent, preserving heat while preventing condensation from forming on the felt. Viewed in sequence, these adaptations form a coherent architectural logic. The yurt is not merely shelter, it is a self-regulating system. Each modification, pole angles, crown height adjustments, weighted felt edges, overlapping seams, is a response to measurable environmental stress. Its circular geometry, compressive and tensile networks, and thermal layering exemplify a pattern repeated wherever humans have had to manipulate lightweight, portable frameworks in extreme climates. Within this broader human record, yurts occupy a specific niche, a transportable, rapidly assembled, climate-adapted envelope that channels material properties and geometry into functional resilience. Even as the wind subsides and the snow begins to melt, the yurt's systems remain in quiet equilibrium. Its lattice, its felt, its hearth, its stakes, all retain their positions, the product of deliberate spatial and material decisions accumulated over generations. The structure does not endure by chance. It endures through the precise calibration of elements responding to elemental pressures. Standing beside it, one observes not comfort or triumph, but the slow, persistent articulation of human ingenuity expressed through material, form, and physics. The landscape around it continues indifferent. Inside, the yurt's systems maintain their measured stability, quiet and exact.